Hello everyone, I'm Professor Ken Maksore. In this today's session, we are going to study how to draw the cam profiles. In the earlier sessions, we have studied to draw the displacement diagram using the uniform velocity, simple harmonic motion, uniform acceleration, retardation, and the circular motion. In this session, we are going to study with the help of these motions how to draw the cam profile for the different followers, that means knife edge follower, roller follower, flat face follower, and the oscillating follower. The objective of this session to that is to student will able to understand how to draw that cam profiles. Now at the end, after studying this, they can design the followers with the different follower motions and the different followers for the industrial applications. These are the some notations. S, which is the stroke length. S, which is the radius of the base circle. Small r, base circle roller radius. Capital R plus small r, which is the radius of the prime circle. N, which is the cam rotation in rpm, which is omega is the angular velocity, theta is the cam angle, theta o is the outstroke angle, theta do, which is the dwell after outstroke, theta r, which is the return stroke, and theta dr, which is the dwell after return stroke. These are the some notations. U v means the uniform velocity, shm, which is the simple harmonic motion, uar means the uniform acceleration retardation, and cyclic motion, which is the cm. Now we'll start with the cam profile for the knife edge follower. According to the follower, we need to design that cam profile. Now in this case, our task is to draw the cam profile for the knife edge follower. Okay. Now we'll just read the problem statement. Here also you have to read that problem statement very carefully. This a disc cam is to give the simple harmonic motion. That means that motion that we are going to consider, which is the simple harmonic motion, to a knife edge follower during outstroke angle of 50 mm. Outstroke, that means this is the stroke length of 50 mm. The angle of ascent is of 120 degrees. Dwell after the ascent, which is of 60 degrees. Angle of descent is of 90 degrees. And remaining that you need to calculate, which is the dwell after the descent. The minimum radius of the cam is the 50 mm. That means this is the base circle radius, which is the capital R. Draw the cam profile when the axis of follower which pass to the axis of the camshaft. That means this is the radial knife edge follower which passes through the center of rotation. Okay. Again, here we need to calculate the maximum velocity and the acceleration during ascent and descent. That part we are not going to focus. Our task is to draw the cam profile. Okay, but you need to concentrate on this also. We already studied this part during while studying that follower motions. You need to follow this. Okay, one thing that you have to keep in mind while using these formulas, while while putting this Vmax, that theta O and theta R, you while taking this, that you have to take in the radians. Okay, next you have to write down the given data as in angular velocity, theta O, theta do, theta r, and the theta dr. Now using this you have to draw the displacement diagram. That part we already studied. For the using the simple harmonic motion, 120 degrees, theta O, theta r, theta dr, cam rotation, vertical axis is the stroke length. Okay, now we'll just start that procedure. You have to see this very carefully. This is very simple. If you get this, you'll definitely get the knowledge how to draw the cam profile. First you have to draw the center O. Next you have to draw one circle, which is the base circle whose radius is equal to 50 mm. Next you have to draw one vertical line through this point. Next you have to draw the knife edge follower because it's line of action which passes through the center of rotation. Okay, now we have to divide this circle into the four parts by taking this as a reference, that vertical line as the reference. Okay, while this you have to consider, while dividing this part, here we are considering the, we are taking that angles in the anti-clockwise direction. That means first in the anti-clockwise direction we'll take the 120 degrees, next 60 degrees, 90 degrees, and the 90 degrees. See, one thing that you have to keep in mind, in this case we are just assuming this cam which is rotating in the clockwise direction. Cam is rotating in the clockwise direction. In that case you have to take these angles in the anti-clockwise direction. If you are assuming that crank is rotating in the anti-clockwise direction, at that time you have to divide this circle into the four parts by taking that angle in the clockwise direction. Okay, like take first angle 120 degrees, next 60 degrees, next 90 degrees, and next again the 90 degrees. Again, here we have divided that theta O outstroke angle into the 6 equal parts, theta R into the 6 equal parts. Here also we have to divide into the 6 equal parts like this. Theta O 6 equal parts, theta R 6 equal parts. Okay. Now you have to give the numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, next task you have to join these points with the center, and you have to just extend that lines by the very faint line like this. Okay. Next task you have to, by using this displacement diagram, you have to measure these distances 1a, 2b, 3c, 4d like this, and you have to mark that points like this. Next you have to give the notations a, b, c, d like this. After giving that notation, you have to just draw a very smooth line through all these points, and you have to join this curve. You have to join all these points. Okay. Again, while joining these F and G, which are the duals, for that you have to take this radius O to F as a radius, and you have to draw one arc up to this G, and you have to draw this portion. For this you have to use the French curve. You need to draw this profile for this portion. Using the compass you have to draw this arc. Again, by using the French curve you have to draw the return curve, and again by using the circle compass you have to draw this circle. Okay. And in this way you can draw the cam profile. You have to give the notations, nomenclature, and you need to finish this that cam profile. In this way you have to draw the knife edge follower, radial knife edge follower, because line of action of this follower which passes to the center of rotation. Now we are going to consider the offset knife edge follower. In this case, that line of action of the follower which is offset by some distance, which is by 20 mm. In this case, that uh, here we need to consider the same problem statement of that previous condition. Only change that we have made, which is the cam, that means line of action of the follower which is offset by the 20 mm distance. According to this, that procedure of the to draw the cam profile gets changed and its shape gets changed. That we need to take care. Again, according to the that available space constraint, we need to take this offset knife edge follower. Okay. Again, in this case, uh, again we need to find out the maximum velocity and maximum acceleration. That part is which is you have to use these formulas. Only one change that we need to take, which is of offset distance is of 20 mm. Okay. Now that again here we have considered the that follower motion with the simple harmonic motion. According by following that procedure, we have drawn this displacement diagram. Now I will just draw this cam profile. Also I will just mark the center, which is O. Next I will draw the base circle. Next I will draw the offset circle whose radius is equal to 20 mm, which is given, and this is the offset circle. Now this point I will draw one vertical line which must be tangent to this offset circle. I will just mark which intersect that base circle at point. That point you need to mark. On that you have to, at that point you have to draw the knife edge follower just like the previous condition. Now you have to join this point, mark point with the O. Okay. Now this is your reference line. With that reference line you need to mark, or you need to divide this circle, base circle, into the four parts. One is the theta O, theta do, theta r, and the theta dr, last part. In this case also we are assuming that cam rotates in the clockwise direction. That's why we have taken this angle in the anti-clockwise direction. Okay. Now again you have to divide this theta O into the 6 equal parts by taking this line as a reference, this line as a reference. This is the first part, theta O into the 6 equal parts. Okay. Again you need to divide this theta r into the 6 equal parts. No need to divide the, because here which parts that we have divided, here we have divided theta O into the 6 equal parts, theta r into the 6 equal parts. Same procedure we have to follow in while drawing the displacement cam profile. Now you have to give the numbers just like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now what we need to do, from this point 1, this is very important stage. From this point 1 you have to draw one line which need which must be tangent to the offset circle, just like this. Okay, like this, and you have to follow the same procedure. Don't take that offset circle. Suppose I want to draw, don't take from this in this orientation. You have to draw the same procedure and same steps to draw that tangent lines. Again, after drawing these tangent lines by using the displacement diagram, you have to take these distances in compass 1a. You have to place that pointer over here and you have to mark the a, b, c, d, e, f, g, h, I, j, k, l, m, like this. You have to give the notations a, b, c, d, like this, e, f, g, h, I, j, k, l, m. Okay, now you have to draw that cam profile. Only you have to concentrate over here for f and the for h. Here you have to take this o to f distance in compass and you have to draw the arc. You have to draw the arc, circular arc, and that point will definitely meet at point G. And for remaining portion, by using the French curve, you have to join this profile and you will find this cam profile. And you have to give the nomenclature. In this way, you need to draw the cam profile for the offset knife edge follower. Now we'll consider the cam profile for the roller follower. If we have the space available and if you want to reduce the wear, we use the roller follower instead of the flat knife edge follower. In this case, if you read the program statement, a cam of base circle of 50 mm wish to operate a roller follower of 20 mm diameter. That means radius of that roller is of 20 mm. The follower is to have the simple harmonic motion. The angular speed is of 360 rpm. Draw the cam profile for a cam lift of 40 mm. That stroke is of 40 mm. Angle of ascent 60 degrees. Angle of dwell after ascent, which is of 40 degrees. Angle of descent is of 90 degrees. And again there is a dwell that we need to calculate. Also calculate the maximum velocity and the acceleration during ascent and descent. We have these formulas, using that you can calculate. Okay, 120, 60, 80, 180 and 90, 90, 180. That means this is of total 360 degrees angle. Okay. Okay. Sorry for this change. That theta is O is of 60 degrees, theta DO is of 40 degrees, theta R, which is again 90 degrees with the simple harmonic motion, and remaining angle which is with the dwell after the return stroke. There is no any follower motion, that's why no need to consider this. Okay. Now again you need to calculate Vmax, Amax as per the procedure. That formulas you need to remember, and using this you have to calculate the maximum velocity during ascent and the descent, or during outstroke and the return stroke. Okay. Now we are going to draw the cam profile. Again you have to draw the displacement diagram with the simple harmonic motion. Theta O, theta DO, theta R and theta DR will be given to that you have to draw, and as per the simple harmonic motion you have to draw the that displacement diagram. Now we are going to draw the cam. Mark this point O. Next, draw one base circle. Through this point, draw one vertical line. On this vertical line, just mark the distance base circle radius plus roller radius. You get this point. Through this point, draw the roller. Okay, this is of O1 actually. Next, through this center, just mark the prime circle. This is the prime circle whose radius is equal to base circle radius plus roller radius. Okay, now this is the base circle. Now just divide with the reference of this vertical line. Here we need to divide this prime circle into the four parts with this theta O, theta DO, theta R and the theta DR. From this vertical line we are going to take that angle in the anti-clockwise direction, because here we are assuming that cam is rotating in the clockwise direction. If you are assuming cam is rotating in the anti-clockwise direction, then you need to take this angle into the clockwise direction. Okay, now this is the theta O, theta DO, theta R, theta DR. Again you have to divide this theta O into the this prime circle into the six equal parts, 1 2 3 4 5 6. Again theta r into the six equal parts, just like this. You have to give the notations that we have given in the displacement diagram. Okay, now these points, you have to join this 1 to 0, again 2 to 0, 3 to 0, and you have to extend this line and you have to draw the very faint lines like this. Okay, now after drawing this line, you have to take 1a, 2b, 3c distances along these faint lines. You have to mark that points a, b, c, d like this. This must be up to this must be in the increasing order. After this it must be in the decreasing order like this. The distance again shorter like this. Now you have to give the notations a, b, c, d like this. After getting this point a, b, c, d, e, f, next you have to draw the circle, roller circle at this point by taking this at the center. That means in this case roller circle radius is of 10. That means you have to take the compass. You have to mark one circle whose radius is equal to 10 mm like this, like this. On all these position you have to draw that circle which radius is equal to 10 mm. Okay, like this. Next you have to draw one cam profile. Now we are at the last stage. You have to draw one profile in a such a way that that profile must be tangent to all the circle. Here you need to use the French curve. You have to adjust these points in a such a way that that circles are tangent to this cam profile. At this location you have to take this distance in compass and you have to draw one circular arc which is again at this position. Okay, for this dual period you have to draw directly circular arc, but for remaining portion you have to draw the French curve. You have to draw this curve with the help of the French curve. Okay, just like this. Okay, this is your cam profile. Okay, and again you have to join this point ABCD, which is your pitch curve. Okay, in this way you need to finish this cam profile and you have to give the proper notations and the nomenclature. You will get the good marks. Now we are going to draw the offset roller follower. In this case, that problem statement is given: a cam with the 60 mm minimum diameter, that means the 30 mm radius, with 20 mm lift, that means the stroke length is of 20 mm, rotating clockwise at a uniform acceleration retardation with the 1200 rpm, has to give the following motion to the roller follower with 10 mm diameter. That means roller radius diameter of that roller which is of 10 mm, that means it's okay, that means its radius is equal to 5 mm. Next, outstroke. Now that follower is to move outstroke for the 120 degrees with the uniform acceleration retardation, again dwell for the next 60 degrees, again return during the 90 degrees. In this case nothing is mentioned, that means you have to consider the uniform acceleration and deceleration, and dwell during the remaining period. Again draw the cam profile if the cam axis is offset by the 20 mm with the follower axis. That means offset distance is given which is of 20 mm, roller diameter is of 10 mm. Okay, now we have to draw this cam profile. All this data we have to consider. Okay, now in this case that stroke length is given according to this. For by using the uniform acceleration retardation motion, you need to draw the displacement diagram. Next, after drawing this displacement diagram, we need to draw the cam profile. Again you have to mark the center point O. Next you have to draw the base circle whose radius is equal to 30 mm. Next you have to draw the offset circle whose radius is equal to 20 mm. Okay, now through this point you have to draw one vertical line. You have to mark this point. I'll just enable this point. When you need to draw this point. Okay, at this point, next you have to consider the radius. Okay, on this line, vertical line, you need to consider the radius of the roller in a such a way that that roller must be tangent to this base circle, and you have to mark this point. Okay, after marking this point you have to draw this circle. Next, through this point you have to draw the prime circle. This is the prime circle. Okay, now after drawing this prime circle, what you need to do, by taking this as a reference, you have to divide this prime circle into the four parts. This is the first part, this is the second part, third part, as we divided into theta O, theta D O, theta R, and the theta R. By that angles are 120 degrees, 60 degrees, 90 degrees, 90 degrees. This total angle is of 120, 60, 90, 90, 90, 90, like this. Okay. Now you have to divide this prime circle into the six equal, that theta O part into the six equal parts, like this. Again, there is no need to divide theta dual after outstroke. Again, you have to divide this theta r into the six equal parts again. Okay, now you have to give the notations like this: 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, next part, just you have to concentrate on the initial position. In the initial position, that circle this line which passes through the center of this roller and which is tangent to this, you need to follow same procedure for all this. That means you have to draw one circle, you have to draw one line which must be tangent to this circle, and which is again passes through this point 1, like this, like this. You have to draw the line through the point 2 which must be tangent to this circle. You have to adjust in the same way, like this, and you have to extend these lines. On these lines you have to draw the, okay, on these lines you have to mark this 1a 2b 3c distances by using this displacement diagram. You have to mark these distances. You have to give the notations a b c d e f g h I j k l. Okay, next you have to draw the circle through these points a b c d e f, just like our previous diagram. Okay, and that radius of that roller is equal to roller radius, which is of 10 mm, sorry 5 mm. Radius is 5 mm, like this, like this. Okay, now you have to draw the, using the French curve, you have to draw that cam profile which must be start from this point, and you have to draw that profile in a such a way that that profile which is tangent to all these circles. By using the French curve, you need to adjust these circles in a such a way that that profile which is tangent to these circles. Okay, for this position, from this to this, for this dual period, you have to take this distance in compass O2, this distance in compass, this distance in compass, and by you have to draw one simple arc by taking this as a radius through this point. You will get this profile, and remaining profile you need to draw using the French curve. In this way you have to draw the cam profile. This is the cam profile and this is the pitch curve. In this way you have to draw the cam profile for the offset roller follower. Now we are going to draw the cam profile for the flat face follower. Okay, in this case we need to draw this with the cyclodal motion. A flat face reciprocating follower has the following motion with the cyclodal motion: angle of ascent 80 degrees, angle of dwell 80 degrees, return stroke 120, and remaining is again of 80 degrees. Okay, next, base circle diameter is of 60 mm, stroke length is of 50 mm. The line of motion of the follower is passed to the, that means this is the radial follower. Okay, now we need to draw the cam profile for the flat face reciprocating follower and the cyclodal motion. Now we'll start to draw the cam profile. Before starting, we need to draw the displacement diagram using the simple harmonic. Sorry, using the cyclodal motion, you need to draw the that displacement diagram by taking the circle. Radius of the circle is equal to r is equal to s upon 2 pi, that s is equal to stroke upon 2 pi. You need to consider this, and you need to follow the procedure of the displacement diagram. That video I have already mentioned, already uploaded. Okay, now we'll start to draw the displacement cam profile. First of all, you have to mark the center, draw the base circle is equal to 50 mm. Next, here you have to draw the that flat face follower. In this case, while drawing that flat face follower, you have to take the maximum distance towards the front and minimum distance at the end. That means this total distance is the 3 times of this total distance that you need to consider. Next, again from this vertical reference, you need to divide this base circle into the 4 parts. One is the outstroke angle, next one is the dwell, next one is the return stroke and the again dwell. Okay, now just like this, here we have divided this dwell into the 6 parts and return stroke into the 6 equal parts. Again here also you need to follow the same. You have to divide that outstroke angle into 6 equal parts and return stroke into the 6 equal parts. Okay, next we have to draw these equal parts that you need to join, or before that you have to give the notations. Now you need to join these parts with the center line, that means the center. You have to draw the faint lines on these points lines. Now you have to mark these distances 1a, 2b, 3c like this, 1a, 2b, 3c like this. Okay, after the marking this point you have to give the notations a, b, c, d that we have already mentioned over here. Okay, after marking these points, now you have to draw the same line, that means flat face, that you have to draw in a such a way that it must be, which must passing through this point A, but again perpendicular to this line, this OA, OB, OC like this. Okay, you need to draw this line in a such a way that that must be perpendicular to the this extended lines. That means O to B. You have to draw that lines which must be perpendicular to this, just like this. Okay, I think these are not visible, but just try to understand this by the yellow lines. Okay, you have to draw this line perpendicular to this OA, OB, OC, OD, OE, OF, OG, OH, OI, OJ, OK, OL, and OM. In this way, you have to draw these perpendicular lines. Next, in the last step, you have to draw that cam. You have to draw the cam profile in a such a way that this profile must be tangent to all these follower positions, and for this up to this portion, you have to take this distance in compass and you have to draw one circular arc and you have to complete the cam profile. Okay, in this way you need to complete the cam profile. Okay, this is the overall method to draw the flat face follower. Just concentrate on this follower position. This must be perpendicular to the this OA, OB, and all these positions. Okay, in the next, in the last profile, which is the cam profile for the oscillating roller follower. In this case, a cam operating an oscillating roller follower having the uniform velocity. Draw the cam profile for a given data below. Next, roller. Okay, in this case, roller center from the center at the beginning of ascent is of 60 mm. Center, roller center to the ascent, this distance is of 60 mm. I will explain you what is mean of this distance. Angle of ascent, medium radius of the cam, which is of 40 mm. Next, that means base circle. Next dwell is of 40 degrees. Angle of ascent is of 90 degrees, and angle of oscillation of the arm, which is of angle of oscillation during ascent and descent is of 15 degrees. Okay, before right now we have just read that problem statement. What is mean of this oscillating roller follower? In oscillating roller follower, which is the one of the type of cam and follower, in which that rotary motion, okay, in this oscillating roller follower, which is one of the type where that rotary motion is converted into the oscillating motion like this, which is the oscillating roller follower. Okay, now in this case, that total angle between the during the ascent, that means ascent and descent, which is of 15 degrees. That means the total angle is of 15 degrees. Okay, and the length of the arm is of the 80 mm. Okay, all these data are given, theta o, theta d o, theta r, and that theta d r that we need to calculate, which is of 165 degrees. 60, 45, 90, remaining angle is of 165 degrees. Length of the arm is of 80 mm, and that roller radius is of the 10 mm. Okay, here what we need to do, we have to draw one 80 mm distance, but that means that length of the arm is given to you. which is of 80 mm, that you need to draw that arm, and you have to rotate this arm through an angle of 15 degrees. Okay, and you have to draw this arc and you have to measure this distance a dash, which is equal to 20.88 mm. This is the total stroke length of this oscillating roller follower, which is given in terms of degrees, but while drawing that displacement diagram we require the stroke which is calculated using this method. Okay, now stroke that we have calculated, or we have the second method. Using this method also you can calculate the stroke just like the arc length. Okay, now we are going to draw the cam profile for the oscillating roller follower. In this case, that first we need to draw the displacement diagram. In this case, displacement diagram for the using the uniform velocity. That stroke length is given that we have calculated. According to that, again from given data we have drawn this displacement diagram. Next task is to draw the cam profile. Okay, here you'll find that all these details are mentioned over here. I'll just draw. First of all, we need to draw the fixed point. Mark the fixed point O, which is the center of rotation of the cam. Next we need to draw the base circle. Next we need to draw the vertical line. On this vertical line again we need to draw the prime circle. That prime circle radius is equal to base circle radius plus roller radius, because in this case this is the oscillating roller follower. That means we need to add the radius of the roller. Okay, next we need to draw the pivot circle. In this pivot circle, the center of rotation of that cam and the center distance between the center of the center of rotation of the cam and the pivot, which are given to us. According to that we need to draw the pivot circle. After getting that pivot circle, next task is to, we also know the length of the follower, but we don't know the exact location of the pivot. For this what we need to do, we have to place your compass over here. We have to take this length of the follower into the compass, and we have to cut the pivot circle, and at this location we'll get the location of the follower like this. Okay, after getting the location of the follower, I'll just erase this. Next we need to join this pivot center and this O1 and this line. Okay, this is now your frame of reference. With this line you need to divide this pivot circle into the four parts. First part is the 60 degrees outstroke angle. Next one is the dwell after outstroke. Next one is the return stroke, and remaining is the 165, which is the dwell after the return stroke. Now we need to divide that pivot circle, that outstroke angle on the pivot circle into the six equal parts like this: A1, B1, C1. Okay, just try to understand. Here I have used the different notation, and here you will find some different notation. We need to use the notations in the next part. Now we have to just divide this into the six equal parts. Again, return stroke again in the six equal parts. Okay, after dividing into these equal parts, now what we need to do, we need to take this distance of the follower into the compass. We need to take distance of the follower into the compass. You have to place your pivot point of the compass at this location, and you need to mark the arc on the prime circle like this. You need to divide this prime circle. Okay, up to the F1 you need to draw these arcs. Next, after G1, H1, like this you need to draw the arcs. After marking these arcs, next task, okay, to give the naming 1 2 3 4 5 6 7 8 9 10 11 12 39, last one is the 14. Okay, after marking these points, next task is to mark this ABCD distances. Again you have to take that 1A distance into the compass. You have to put your pivot point of the compass at this location. You have to mark the point A. Just like this you have to mark the point B, C, D, E. By placing that on the respective points, you will get these points. After getting these points, just like the roller follower, you need to draw the roller circles at point A, B, C, D, E, F, G, H, I, J, K, L, M, like this, like this. After marking all the circles, okay, again just like the roller follower method, we need to draw one line which must be tangent to all these circles. Okay, in this way you need to draw the cam profile for the oscillating roller follower. In this case you have to give the notations: base circle, prime circle, pivot circle, okay, pitch circle. Okay, in this way we we have started with the knife edge follower and we ends with the oscillating roller follower. In this total session we learn the knife edge follower, radial knife edge follower, offset knife edge follower, next radial roller follower, next offset roller follower, next one is the flat face follower, and last one is the oscillating roller follower. In this way we learn all the type of cam profiles with the different follower motions and the different followers. With this I will finish my session over here. Thank you for your patience listening. Thank you very much.